Okay, so now let's talk about phase transitions. Okay, so remember our central question from our discussion of intermolecular forces. And we started by saying that the physical state of matter depends on the balance between kinetic energies of the particles and the strengths of their interparticle attractions or intermolecular forces. So our question was, why is a particular substance a gas, liquid, or solid at some given temperature? And that has to do with the strengths of intermolecular forces. Now we know what those are. Now we know how to analyze them and assess them. And so substances that are gases at room temperature have relatively low intermolecular attractions, where solids have the strongest intermolecular attractions at the same temperature. And liquids are somewhere in between, so they have intermediate strengths of attractions. Okay, so in order to illustrate these phase transitions, we are going to start with a piece of ice. And we're going to think about the structure and what's going to happen to it as we heat it up. So we're going to start at 1 atmosphere pressure and -5 degrees C, which is below the freezing point, of course. Now, when water freezes into ice, it has a hexagonal crystal structure, and it's held together with hydrogen bonds between the water molecules. So you can see all of those here. Now, below 0 degrees C, so in other words, at low enough temperature, the kinetic energy of the water molecules isn't high enough to ruin these hydrogen bonds. Okay, so these water molecules aren't jiggling around enough to start shaking loose from those hydrogen bonds. So they're held into place in this hexagonal crystal structure. Now, as we increase the temperature, the kinetic energy of the water molecules increases as heat flows into the ice cube, and it starts to disrupt those hydrogen bonds. But of course, it's still a liquid as the ice cube melts, so those hydrogen bonds can reform. So they'll form, break apart, reform, form, break apart, reform. And so the ice cube is melting because basically now that balance between kinetic energy and potential energy is starting to increase a little bit more toward the kinetic energy side. So molecules will be able to actually move around in that liquid. Now, as we keep on increasing the temperature to 100 degrees C, so what happens at 100 degrees C? Well, the water boils. And so at this point, the kinetic energy of the water molecules is quite high, and some of those water molecules can even escape. They even have enough kinetic energy to overcome that attractive potential, those hydrogen bonds, and escape the liquid entirely into the gas phase. Now, it's not as obvious, but if you change the pressure, you could change the physical state of matter as well. Okay? So the general idea is that as you increase the external pressure on some gas at constant temperature, the phase is going to change from a gas to a liquid to a solid. Now, this little picture is one that I used in the van der Waals real gas discussion. So we have 3 scenarios for gases in a piston. And we're going to start with this first scenario here. So we just have gas in a cylinder. It has plenty of room to move around. Now, as we increase the external pressure, so the pressure pushing down on this piston, it reduces the volume, molecules get closer together, and they start to cluster a little bit as they're forced closer together. So now they're beginning to feel each other's presence. Okay, so they're starting to experience some intermolecular attractions. Now, if we keep increasing the pressure, so if we keep increasing the pressure to this point, then now we've basically forced all of those molecules tightly together. It's going to condense to a liquid and then to a solid. Now, there is an exception for water. Water is actually the other way around. But most substances, it's going to go from a liquid and then to a solid as you increase the pressure. And that's a weak dependence, but there's a small dependence. Okay, so some of the major types of phase transitions that we are going to talk about in the next couple of videos: melting, also called fusion, and that's a transition from solid to a liquid. evaporation or vaporization, and that's liquid to vapor, sublimation, solid to vapor, condensation, vapor to liquid, freezing, also called solidification, and that's liquid to solid, and finally deposition, where we take a vapor and it transitions to a solid. Okay, so the next thing we're going to talk about is vapor pressure.